In this video, I'm going to talk to you about defining a system. And I want to do this through the context of Newton's third law and Newton's third law force pairs. In this scenario, we have a physics book resting on top of a biotechnology book, and both are resting on top of a desk. We want to draw some free body diagrams for both books, and then lastly, we're going to calculate force normal for the biotech book. Now, as we're doing this, I'm going to talk to you about defining a system, and also I want to reinforce what you learned in previous video on Newton's third law of force pairs. So let's go ahead and get started. Let's begin by doing our free body diagrams. Now, as we're doing these, we will have force normal, we will have force of gravity, but I'm actually going to label them using two objects, again, for reasons to reinforce what you learned about in the previous video. So we have a total of 4 objects that are involved in our free body diagrams. Let's start with the physics book. We have the upward force of the biotech book onto the physics book. And yes, that is force normal. We also have the downward force of the earth onto the physics book, which is the force of gravity. Now let's look at the biotechnology book. We have the downward force of the earth on the biotech book, but we also have the downward force of the physics book onto the biotech book. So there's a contact force there occurring as well. So there are 2 downward forces. Notice the relative lengths of the arrows on these free body diagrams, which relate to the magnitude of the respective forces. Lastly, we have the upward force of the desk onto the biotech book, which is force normal. But notice that its magnitude is greater than the physics book, and notice that the length of it will sum to the lengths of these 2 downward forces, making them equal in magnitude, opposite in direction. Now, for the biotech book, the upward force of the desk onto the biotech book is force normal. So we'll call it that when we sum the forces here. And the downward force of the earth on the biotech book, as we've said, is the force of gravity. So let us sum the forces vertically for the biotechnology book so we can calculate force normal. Now, I know that there are 2 downward forces and 1 upward force, and we can define our coordinate system calling up positive and down negative. So I'm subtracting both the force of gravity and the force of the physics book on the biotech book from force normal. Now, you know that there's no net force and therefore no acceleration. So the right side of this equation becomes 0. Therefore, force normal is equal to the sum of both force of gravity and the force of the physics book onto the biotech book. So let's go ahead and put in some numbers here. And if you're wondering where those came from, they simply come from the mass of each of the books multiplied by the acceleration due to gravity to give us 15 and 10 newtons. So when we sum those together, we get obviously 25 newtons. Now I want you to pause and look at the free body diagrams. I want you to pause the video and choose all of the Newton's third law of force pairs involved in these free body diagrams. Well, labeled on here, there's only one mutual pair. They are now highlighted in yellow. We have the upward force of the biotech book on the physics book, and we have the downward force of the physics book on to the biotech book. Now, some of you might say, hey, wait a minute. These forces here are equal in magnitude and opposite in direction. Remember, guys, that's a huge misconception. True, For this scenario, they are equal in magnitude, opposite in direction, but they are not Newton's third law of force pairs, because in that scenario, we have three different objects. Just look at the subscripts used. We have B, P, and E. So we have the biotech book, the physics book, and the Earth. Again, the only mutual pair in this scenario on these two free body diagrams would be the pair highlighted in yellow. Lastly, let's talk about defining a system, which is an intuitive approach to solving these types of problems. You define the system. So I could say, well, I want to define my system to be comprised of two objects, the biotech book and the physics book. That is my defined system. And that defined system has a composite mass of 2.5 kilograms. And 2.5 kilograms multiplied by the acceleration due to gravity will give me 25 newtons, being the upward force of the desk onto the two object system, which is force normal for the biotechnology book. Okay, so you define your system. So in this video, I've taught you how to evaluate and define your system. We've also looked at another example of a situation that involved an interaction among several objects, and you were tasked to find and identify the mutual pair identified as a Newton's third law force pair. And I'll see you guys in class.